there is one more test we can have, and that is nothing but the comparison test. But before that, we write one result that is called as P series, because that result will be useful. Now, what is that P series? So if you have the series like this, series n equal to 1 to infinity, 1 upon n power p. That means 1 over 1 power p, 2 power p, 3 power p, and so on. That is called the P series. And this P series is convergent if P is greater than 1, and divergent if P is less than or equal to 1. That you need to remember. Because of lack of time, I'm not going to prove this, but otherwise if you want to prove, it's easy to prove by using integral test. We can prove this by using the integral test. Okay? But right now we are not going to prove. We just need to remember this like this. Say, so this result you need to remember. This is a result. Like series 1 upon n square, like 1 upon 1 plus 1 upon 2 square, 1 upon 3 square, 1 upon 4 square, and so on. So this is a P series. What is P here?
2.
P is 2. So what is your conclusion? Whether this series convergent or divergent?
Convergent.
Because yes, convergent, but
because P is greater than 1.
P greater than 1. So P is greater than 1, and therefore series n equal to 1 to infinity 1 upon n square is convergent. Okay. What is the sum? We don't know, but at least we know the sum is possible. Okay. At this point of time, we don't know what is the exact sum, but we can at least say that this series is convergent. That means the sum is possible. What about this series? Convergent or divergent?
So divergent.
Convergent.
Okay. Decide. Convergent कौन बोल रहे? Divergent or convergent?
Divergent.
Hello? Divergent. Why? Because
P
what
is
is
equals
P
to
here?
1.
P equal to 1. And see that if P is less than or equal to 1, less than or equal to 1. So this is P less than or equal to 1 category. Okay, because equal to 1. So therefore, this series is divergent. Same example can be solved by using the integral test also. These, okay. Like series 1 upon n. So that is an equal to fn equal to 1 upon n. Okay. See this one the thing. Or you can say fx is 1 upon x. And this is continuous, positive, and decreasing. Okay. So integration 1 to infinity fx dx, integration 1 to infinity 1 upon x dx. You know, this integration is log x, and this tends to infinity because log infinity is infinity. That means this integration does not have any finite value. That means this integration is divergent. And therefore, by integral test, series 1 upon n is divergent both way, either by p series or this way. Now, what is this? What is peculiarity of this series? This is known as harmonic series. This is known as harmonic series. You know, there is one nth term divergent test. What was that test? That test like this: if series an is convergent, then limit n tends to infinity, an is 0. Okay, that was the things that we, and we already said that converse is not true. Converse is not true meaning what? Limit n tends to infinity, an may be 0, but the series an equal to 0, but the series is not convergent. Okay, so this is an example where you can see that limit n tends to infinity 1 upon n equal to 0, but series n equal to 1 to infinity an, that means 1 upon n, is divergent. So this theorem is one side only, it's not two-sided theorem. Understood?
Yes, sir.
Okay. Now, what about this series, convergent or divergent?
Divergent.
Divergent. What is P here?
1 by 2.
1 by 2. And which is less than or equal to 1. Okay, less than 1. And therefore, this series is divergent. What can you say about this? What is P here?
Sir, 2.7 something. Like
Yeah, so
conversion.
E. And this is greater
E.
than 1. So therefore, this series is convergent. Agree, everyone? So this is about the P series and convergent divergent. Okay. Now, there is one test and it is known as comparison test. So comparison test. One is known as direct. Okay. One is known as direct comparison and another is known as limit comparison. One is known as direct comparison and another is known as limit comparison. Now, so here you are having series an that you are given and you want to check whether it is convergent or divergent. That we would like to check. Okay. Now in direct comparison, see now you know some non-series. Non-series are P series, geometric series. These are all non-series. So if you can able to find out, some series say Cn, if you can able to find out some series say Cn, okay, this is we need to choose. And if that series is like this, an less than or equal to cn, an less than or equal to cn. Okay. An less than or equal to cn. For all n, it may not be from 1, it may be from some number also, okay, like this. And if series cn is convergent, this is non-series, okay, convergent, then series an is convergent. Easy to understand because cn is convergent, series cn is convergent, and our series term is less than or equal to that. So if you can find out the sum of this series cn, then because an is lesser than that, we can also find out the sum. That means sum is possible. Okay, so very easy to understand. And if an is greater than or equal to cn, for all n greater than or equal to n, and series cn is divergent. That means series cn sum is not possible. તો હવે an ના ટર્મ્સ તો cn થી બી વધારે છે, મોટા છે. તો જો cn નો સમ પોસિબલ નથી તો an નો પણ સમ પોસિબલ. Then series an is divergent. Okay, so this is direct comparison test. This is known as direct comparison test. Then there is one limit comparison test. Okay, we take one example of direct comparison test. You can easily find out, like this. Series 1 upon n factorial. One upon n factorial. Now, can you say like this? So this series is 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus 1 upon 4 factorial and so on. Okay. Can you write this? Like all the terms here is 1. It's okay. But from this term onward, less than or equal to 1 by 2 plus 1 by 4. This is 1 by 6 and this is 1 by 4. So 1 by 6 is less than or equal to 1 by 4, isn't it? 1 by 8, this is 4 factorial and this is 8. You understand, everyone? Hello?
Yes, sir.
So આ
Yes, sir.
terms છે આટલા terms એ આનાથી નાના છે. What is this series? This is like this, 1 upon 2 power n, isn't it? So our series Cn
Yeah.
is 1 upon 2 power n. Is it convergent or divergent? This is geometric series. And this is convergent because our ratio is 1 by 2 and which is less than 1. So આપેલી series છે એ કોઈ convergent series થી નાની છે. So therefore by direct comparison test, series 1 upon n factorial is convergent. Understand, everyone?
Yes, sir.
Yes.
Yes,
Yeah.
sir.
So you can write down this example. Return this example.
Yes, sir.
Okay.
Yes, sir.
Okay. So next we take uh, statement of this limit comparison test. So let us see what is that. Same way, here you are given series AN. Now there is one series, say series BN, and that is non-series. Behavior is non. Okay, whether it is convergent, divergent, that we know. Okay. Now you find out some limit, like limit n tends to infinity, AN upon BN. And if this limit is some positive number, like c greater than 0, then series AN and series BN both converge or both diverge. What does it mean? If BN is convergent, AN is convergent. If BN is divergent, AN is divergent. You need to find out this kind of limit. Now, if this limit is suppose 0, so if limit n tends to infinity, AN upon BN is supposed to 0, then it is like this. So if limit is 0, then series AN is divergent if series BN is divergent. એટલે કે જો BN divergent હોય તો AN divergent, પણ BN convergent હોય તો AN convergent ના કહી શકાય જો લિમિટ 0 આવે. તે જ રીતે લિમિટ ઇન્ફિનિટી આવે. If the limit is infinity. Sorry, मैं भूल करी. અહીંયા ભૂલ કરી. Series AN is convergent. Series AN is convergent. एक minute. Pencil not working. Okay. So here it is said like this. Series AN is convergent if series BN is convergent. First one 0 હોય ત્યારે. Okay. Okay, એક minute. મારી ભૂલ. Not able to use the pen. Oh. Okay. If series BN is convergent. Okay. And if this limit is infinity, then series AN is divergent if series BN is divergent. એટલે કે infinity હોય અને BN divergent. Infinity and BN divergent, then AN is divergent. 0 and BN convergent, then an converge. I will take the example, but you need to write down this statement of the theorem. So write down this statement. And it's easy to apply this theorem. And you will definitely have one or two example of comparison test, 100%. Okay, everyone.
Yes, sir.
Written.
हाँ sir.
Okay. Now, so let us have the theorem. Okay, example. આનો પણ એક example લઈએ ચાલો. Same direct comparison test નો બી. Like this. Series n equal to 1 to infinity sin square n upon 2 power n. So this is our series an. So an is like this. Now can you say this sin square n upon 2 power n is less than or equal to 1 upon 2 power n? Yes or no? Because what is the range of sine function?
0 to 1.
No.
0, 0 to pi.
Range of sine is minus 1 to 1.
And minus 1 to 1.
But here you are having sine square. So range of sine square is 0 to 1.
1.
Okay, so sine square n is always less than or equal to 1. So this is 1 upon 2 power n. So this is now series, you can take 1 upon 2 power n as series Cn, and it is convergent. Why? Because it's a geometric series. And r equal to 1 upon 2 less than 1. So this is convergent, and our series is smaller than the convergent series. So by direct comparison test, series sine square n upon 2 power n is convergent. You understand, everyone?
Yes.
Okay. Now, okay, have you written? Have you written this example?
Yes, sir.
Okay. Now see, the question is test the convergence. The series n equal to 1 to infinity 10 n plus 1 upon n, n plus 1, n plus 2. Now say this is series AN. Now we need to select the series BN. We are using this theorem. So we select the series BN. Let us see how we select the series BN. Let us see how. Okay. So that Bn. Now see, what is the power here in numerator? 1. What is the power on in denominator? Degree? 3 degree? 1, 2, 3. N cube આવશે અને અહીંયા 10 n. Okay. What is the difference of power? 2. 3 and 1. So select Bn like this, 1 upon n. Select 1 upon n square. Okay. Now you take limit n tends to infinity, an upon bn. This limit n tends to infinity, an upon bn. This one. And let us find out limit n tends to infinity, an upon bn. So limit n tends to infinity. What is an? 10n plus 1 upon n, n plus 1, n plus 2. Divide by bn. Bn is 1 upon n square. So it will be here. Agree or no?
Yes, sir. Yes, sir.
Can you have the limit? Here you take n outside. So here you will have 10 plus 1 upon n. N cube. Here you take n outside. Here also you take n outside. So n cube. So here 1 plus 1 upon n. 1 plus 2 upon n. And now you take n tends to infinity. This 1 upon n 0. So you'll have 10 upon 1 into 1. So this is 10. And that is greater than 0. So this is first thing. C greater than 0. So then both the series converge or diverge together. એટલે કે જેવી bn હશે એવી જ an હશે. Now what can you say about series bn? What can you say about series bn? Convergent or divergent?
Convergent, sir.
Convergent. Why?
P is
Sir,
greater than 1.
It's a p series. And p equal to 2
2,
greater
which
than
is greater
1.
than 1.
So bn convergent. So therefore, by limit comparison test, series an is also convergent. Okay, everyone, understood?
Yes, sir.
You can write down quickly. Okay, written.
Yes, sir.
Yes, sir.
Okay. Let us have one more example. Fine. So check the convergence of this 3 by 4, 5 by 9, 7 by 16, 9 by 25, and so on. So first of all, we need to find the what is that series. So 3, 5, 7, and 7, 9, and so on. So it's a AP, arithmetic progression. What is the difference? 2. What is the first term? 3. What is the formula? A plus n minus 1 into D. So 3 plus n minus 1 into 2. So 2n plus 1. Okay. And what is this one? 4, 9, 16, 25. These are all square, perfect square.
N square.
Okay, not n square because this is 2 and our first term is 1. So this is n plus 1. Agree or no?
Yes, sir.
So this series is like this. Now see, what is the difference of degree? Here the degree is 1. Here the degree 2. What is the difference? 1. So let Bn is 1 upon n. Take Bn is 1 upon n. Okay. Now limit n tends to infinity. This is series An. So limit n tends to infinity. An upon Bn. So limit n tends to infinity. 2n plus 1 upon n square plus 2n plus 1 and upon Bn upon 1 upon n. So it will be n. And so limit n tends to infinity. Here you can take n outside. So 2 plus 1 upon n. And here you can take n square outside. So 1 plus 2 by n plus 1 by n. And what is the limit? This is 2. This limit is 0, this limit 0, this limit 0, this limit 0. So 2 upon 1. So that is 2. This is greater than 0. So therefore, both series An and series Bn converge or diverge together. Now what can you say about series Bn? Is convergent or divergent? Is divergent.
Divergent,
It's a
sir.
harmonic series. Yeah, it's a harmonic series. It's p equal to 1. And therefore, by limit comparison test, our given series like this 3 by 4, say plus 5 by 9, say plus 7 by 16, plus and so on, is divergent. Understand everyone?
Yes, sir.
Yeah. So you can write down this.